Okay, so once we know how to compare both the degree of the top and the bottom, we can apply that information to writing the equation of the horizontal asymptote. So in the first case, if the degree of the top is less than the degree of the bottom, then that means I can write an equation using our standard form values up here. T is the degree of the top. In this case, T is less than B. That means that the horizontal asymptote itself is equivalent to my vertical shift value of V. So I'll show you how this works with these two examples. Okay, let's examine the degree of the top here. The degree of the top in this first example is 1, and the degree of the bottom is 2. 1 being less than 2 means that my vertical shift value has an equation of, or my horizontal asymptote has an equation of -1 and is equivalent to the vertical shift. My horizontal asymptotes I always write with the equation y equals. In this case I would say y equals -1, and I can draw that on my graph as such. Just a line at y equals -1. We won't worry about the vertical asymptotes at this point. We'll get to that in a separate video. Okay, so let's do the same thing with this next example. The degree of the top here, there's no variable, so I know that my degree of the top is 0. The degree of the bottom is 1. 0 is less than 1, meaning that my horizontal asymptote has an equation equivalent to the vertical shift. Notice that there's no vertical shift value, there's no plus or minus anything next to the fraction. That means that my vertical shift, V, equals 0. So my equation of my horizontal asymptote is y equals 0, and I can just draw that into my graph. Can zoom in a little bit here. My horizontal asymptote is the line y equals 0 right along the x-axis. If, on the other hand, the degree of the top is equivalent to the degree of the bottom, we do something a little different. So let me scroll up a little bit here so we can take a look at my standard form graph. So if the degree of the top, we'll say t, is equivalent to the degree of the bottom, b, then I take the ratio of the coefficients, that's c over d, and I add them to the vertical shift. So we'll do a few examples to show you what that looks like in actual equations. So let me write that down here. I take the degree, the coefficients, the ratio of the coefficients, and I add them to the vertical shift if the degree of the top is equivalent to that of the bottom. Okay, so in my first example, the degree of the top is 1, the degree of the bottom is 1. That means I take the ratio of their coefficients, 3 divided by 2, and I add them to my vertical shift. So I subtract 2. This is equivalent to -1/2. So the equation of my horizontal asymptote here is -1/2, which is the same thing as -0.5. So I can draw that in to my graph. So that's where my horizontal asymptote is. Okay, that's one example. We'll do the next one here. So the degree of the top here is 2, degree of the bottom is 2. So I'm going to take the ratio of their coefficients. The coefficients of these values are both 1. So I'm going to say 1 over 1, and there's no vertical shift value, so I'm going to say plus 0. My horizontal asymptote has an equation of y equals 1, which will look like that. Do one more example. Okay. The degree of the top here is 4. Again, I'm looking for the highest exponent value, not just the first one. The degree of the bottom is 4 as well. So that means I take the ratio of the coefficients that are connected to the variables with the highest exponents. This is 9 divided by -3, and then I'm going to add 1 here. So this is equivalent to -3 plus 1, which is equal to -2. So my graph will have a horizontal asymptote at -2, which looks like that. So that's how you do the horizontal asymptotes.